Hey, linear algebra. I just wanted to set the stage for section 6.1, but before we do that, I want to give you today's stat. So, here we go. What percentage of all Irish barley what percentage of all barley grown in Ireland goes toward the production of Guinness beer? Let me know what you think, and I will tell you the answer next time. So now let's talk a little bit about section 6.1. So here's the first question I want to ask you. If I have 2 points, what is the shortest path between them? Wait for it. Does it go like this? Probably not. Obviously, it's going to be a line. So then a follow-up question to that is, what's the length of that line? Well, we have something called the distance formula. So once we have coordinates here and here, we could use the distance formula to find the length of the line that connects these guys. Okay, question 2. How does the answer change? Let's look at this one first. If I want to know the shortest path between a point and a line. So you could think of this now as this is our 0-dimensional subspace and this is a 1-dimensional subspace. So what's the fastest way to get from a 0-dimensional subspace to a 1-dimensional subspace? Think about it. Would it be that one? That one? That? Obviously, it's going to be some sort of line, but it's a really special line. It would be the line that goes to it perpendicularly. I meant to use a color that would stand out. Here's one of the old stats, then you can see. So a perpendicular would be the fastest way. Now here, what if I want to know the fastest way between a 0-dimensional subspace and a 2-dimensional subspace? So a point and a plane. Again, that fastest path is going to be a line, but it's not going to be this line because this one will be even faster. So it's, again, going to be the one that cuts into this plane perpendicularly. So here's another question. What about for 2 parallel planes? So I've got these 2 parallel planes. Obviously, so if they're not parallel, this question's pretty stupid. Because if they're not parallel, they're going to cross. So the fastest way between them is, they actually cross. So you don't have to go between them. So this is only interesting if we look at the 2 parallel planes. So to get the distance between these 2 planes, what do you think we should do? This one I'm not going to give you the answer to. But I'm hoping that you're seeing that there's this sort of interesting dynamic between the concept of distance, shortest paths, and angles, this idea of perpendicularity. And geometry, as you know, is all about distances and angles and shapes and things like that. So what this chapter sets us up to do is put a way of measuring distances and angles into Rn. And it's going to give us some tools in linear algebra to do that. So these are the big ideas that you're going to see coming up in chapter 6.1. Distance, lines, something called orthogonality, which is also perpendicularity, so meeting at right angles, and angles. And the tool for this is something called the inner product, also known as the dot product. So the inner product is going to give us a notion of length or norms, and it's from there we're going to get an idea of distance. Length and norm will also allow us to define something called a unit vector, which is just a vector with length 1. And also from the dot product we'll be able to define angles. So I'm just going to quickly show you a couple formulas, but when you do the practice and when you take your notes, you'll see how these all fit together. So the dot product is defined actually in 2 different ways. I call this way the algebraic definition. So we take the transpose of one vector, so we're writing it horizontally, and multiply it by the other vector, which we write vertically, And that's going to give us, so we would do u1 times v1 plus u2 times v2 all the way down un times vn. So I call that the algebraic definition. And from there we get this concept of norm, which is when we take the dot product of a vector with itself. That gives us the norm squared. So this looks similar to distance, and that's a good way to think about it, because really you're measuring like the distance from the starting point of the vector to the ending point of the vector when you take the norm. It also allows us to compute the distance between 2 points, which we think of as the endpoints of u and v. So this connecting vector is u minus v. So if I want the distance between the two terminal points, all I need is the length of u minus v, which is the norm of u minus v, which is how we define the distance. Now there's also a geometric definition of distance, which is the norm of u times the norm of v times cosine of the angle between them, which allows us to write an angle. And finally, once we have this idea of an angle, we have this idea of orthogonal or perpendicular. So you'll work on some practice problems and some thinking questions that tell you properties related to this. But the main thing is that two vectors are orthogonal if they have a dot product of 0. And finally, this allows us to define something called the orthogonal complement, which is going to look similar to this idea that we were thinking about before. So if I have a line, its orthogonal complement is all of the vectors that are orthogonal or perpendicular to that line. So it actually ends up being a plane. And if you think about it, each of these lines on the plane is perpendicular to the line that we started with. Sorry about that. So these are some of the big ideas, the geometry type ideas. Now, before I let you go, there's one other thing that I want to show you. And that's an application of the vector dot product, work. So the two questions to think about here are, which direction am I going to pull this wagon if I want to work the least hard? Well, you might imagine that you'd pull it that way, and you'd be right. Now, what if I'm trying to go up a ramp? You'd want to, again, pull it parallel to the ramp. But if you're pulling at a different angle, then how much work are you doing to pull it this way? So this is a concept in physics that the dot product really helps us to understand, and you're going to play with that in the introductory assignment. So that's all from me. Oh, and I think I had the video messed up before. I was trying to show you the stat. I think I didn't have my face on it. So anyway, good luck with this, and I hope that I set the stage for understanding the geometry that's going on in the background, and let me know if you have any questions. Talk to you all later. Bye.